Hi, in this video I would like to explain about the gravitational constant, also referred to as the big G, and it applies between any two bodies in the universe and on planet Earth as well. You see a sun on the right hand side and an earth on the left. The earth has two motions. It rotates around its own axis and it also revolves around the sun in a huge orbit, and that orbit can be described as nearly circular. In the middle between them I have put in a double-sided arrow, and that shows that the earth attracts the sun towards it and the sun attracts the earth towards itself, and this is called the gravitational force of attraction, which is mutual between any two bodies in the universe. The whole story is about gravitational force of attraction, and from that equation for force we will go on to talk about the gravitational constant. So here you can see the sun is twirling the earth around as if we were in the center and the earth is at the end of a string and the earth is being twirled around. So therefore the analogy is very close to centripetal force, and the gravitational force of attraction here is being used like a centripetal force, and that's a force that keeps the earth moving for millions and millions of years. I hope this gives you a sense of the gravitational force of attraction. Now we will get into the equation itself. So F, the gravitational force of attraction, is proportional to m1 m2 by r square, where m1 is the mass of the earth, m2 is the mass of the sun in this case, and r square is the square of the distance between sun and earth, not the radius. R is the distance. So because it's proportional to, when we say F is equal to, we have to put a constant of proportionality, and that's G, the gravitational constant. And it has a value 6.673 into 10 to the power minus 11. Now let's use these values and calculate the real force between the sun and the earth. You can substitute the values shown there into that equation, and you will get the value of the force as 3.52 into 10 to the power 22 newtons. The value of G, 6.673 into 10 to the power minus 11, is constant throughout the universe. It applies between the moon and the earth, between the earth and the sun, and so on. We'll now take this example. We have our own moon lander which is sitting on the moon. We are on the moon and we are looking at home, which is in the distance, and the moon is rotating around the earth. So the force of attraction between the moon and the earth is what we would be interested in. So again, put the same equation, F is equal to G m1 m2 by r squared, substitute the mass of the earth, the mass of the moon, and r here would be the distance between the earth and the moon. When you do that, you'll get the force of attraction as 1.9857 into 10 to the power 20 newtons. Here again the gravitational constant G is really constant. It doesn't change. So using this gravitational constant, we can find the force of attraction between a planet and a comet, a moon and a comet, and so on. Now we must look at the difference of the big G from the small g, which is acceleration due to gravity. And let's derive the small g. So let's take a mass sitting on the surface of the earth. The earth is a big ball and there's a mass sitting on it. Let that mass be m1. So plug in the same equation, F is equal to G m1 m2 by r square. m1 is the mass that we put on the ground. Keep it aside. Club the other things as G m2 by r squared. So we know the value of G, we know the mass of the earth, we know the R. The R really is nothing but the distance to the center of the earth, which is nothing but the radius of the earth, because we put a box on the ground. So plugging that in, you get F is equal to m1 into 9.8. Now this is a very familiar form of equation. We know that force is mass into acceleration. So if F is equal to some mass into 9.8, that 9.8 must be an acceleration. And therefore, the word G came into existence. G is the acceleration due to gravity, and that's equal to 9.8 meters per second square. Using this value of g, we can calculate the weight of any object as different from its mass. So if the mass is 50 kg, the weight is the force with which the mass is pulled towards the center of the earth. So that force is mass into g, 59.8, 490 Newton. And I hope this clarifies the difference between the big G and the small g. In summary, the gravitational force of attraction is valid between any two objects in the universe which have a mass. It's also valid between a bus and another bus on the earth, between a train and a train, and so on. I hope that this video was useful to you. Thank you and have a great day.